be your quiz today on Friday. So you want to be studying as well pages 26 through 35 technically. So use your time to probably be studying while I'm going around checking the homework. And as we're going over the homework, if you get confused on something, make sure, gentlemen in here, that you raise your hands and ask a question so that way we can fix it before we take our quiz today. You have 2, 4, and 5. Yes, Ethan?
Did you hear Flat Paper died? I was so sad.
laughed.
Okay,
I
be
was
nice.
sad. I was
Use your
so
time.
sad.
Use your time. Use your time. Alright, be sure to show your work as well. So with
They don't halfway.
I know, but write it on a piece of paper because that'll help me to see what you're doing and how to do it. Now remember, it'll be incomplete if you just write numbers down. Same thing goes for you, Chris. If you write just numbers down, same thing like for math, is I have to be able to see because if you just write random stuff or if you write stuff, I don't know how to help you. But it looks like you might have gotten it right, but we'll see as we go over it.
I swear if I get that right.
I'm very happy. Alright, so let's go over 2 and 4 first, and then we'll talk through number 5. We'll probably get some more practice with number 5 as well, because I went through it, but then I just ran out of time. Alright, so number 2, classify each of the following as changes as chemical or physical. You're 50-50 shot for just guessing correctly, so we'll just alternate between you two. Alright, so letter A, Chris, what you got? Cutting meat.
Physical.
That's physical. Really just chop meat from a larger piece into a smaller piece. Alright, Ethan, what do you got for B? Leaves changing color in autumn.
I had chemical, but I changed to physical.
Why?
Because it's nature.
Alright, so is it a chemical
It's
change?
chemical.
It is a chemical change. It's
I
not
was
leaves. You
confused.
were right. But yes, it's not just like the leaves just re-dye themselves. Because of chemical changes, that's why that they're changing colors. Alright, letter C, Chris, what you got?
Chemical.
Good job. Baking a cake is chemical. Alright, magnetizing a nail. Ethan.
This is D.
D.
Is physical.
It is physical because it's just getting basically a magnetic charge. It's not changing anything. Alright, E, cutting the grass.
Physical.
Yep, because the grass is just getting shorter. Lighting a candle.
Chemical.
Chemical, the candle is now burning. Alright, then that was it for A through F. Alright, number 3, nope, we skipped over that. Number 4, how many protons, neutrons, and electrons does each of the following atoms contain? Alright, Chris, what you got for the hydrogen ion? What do you have for that one?
200.
Okay, not sure which it is for this one, so let's talk through it. Alright, so H2 plus. Alright, so how many protons?
2.
No.
3.
Nope. Alright, based on the periodic table in your book, how many protons does a hydrogen atom have? Or you can look at it. 1! Now, they didn't write it down here, but remember the atomic number goes up here, mass number goes up here. So, they didn't give it to you because they assumed you can look it up in your book. So, that's probably reasons why. Alright, so 1 proton. Alright, how many neutrons then?
2.
Nope.
1.
1. Remember, this is a mass number. So, proton and neutron together make this up. 1, and then it's hydrogen with a plus sign. What? 110. So you're right, no electrons. Since it has that 1 proton, it automatically has a plus 1 charge. So because of that, if it's going to be a plus 1 ion, that means it has to have no electrons. Alright, any questions about that though?
No.
Alright,
I missed all of them.
we do them really quick then, because you need to know how to do this, because quiz today.
It's all the quiz today.
You need to know how to do this. One reason why we practice so much on Friday. Alright, so letter B. Alright, what do you got for that one for helium?
2,
Good
4,
job.
and 2.
Good job. Alright, Chris, this will give you practice for this one. So FR, it has 203. I'll tell you for this one, since you don't have time, look it up in your book, but 87 protons.
I have 223.
What?
I have 223. I just didn't have the protons.
Okay, so 87 protons, how many neutrons then? Figure it out really fast. If you want to type it in your calculator, you can.
106.
You're close.
116.
Not quite. Add 2 more, add 20 to it. 136 neutrons. And then how many and then how many electrons is it if it is a neutral atom?
136? No, 287.
87. Good job. Alright. Letter D. Ethan, what you got? Calcium.
20.
Good job.
20.
Whoa. How many for neutrons? I just couldn't hear you.
10.
Nope.
20.
Not just 20.
20.
Alright, so if it's 44, 24 for the mass.
24?
What?
24?
24. So you're right that there's 20 protons, so 24. You probably just did it too fast. Alright, and then it's a 2 plus ion.
18?
Not 18. Oh, oh, the wrong one. Yes, 18.
I thought
But you're
so.
right. I looked at the wrong answer. 18. Alright, anyone have any questions about this one? Alright, let's go over to you, Chris, and we'll solve it fast. So 78 with selenium. Alright, so this one has 34 protons. So how many neutrons does it have?
44.
Good job. And then how many electrons? It has a 2 negative charge.
36.
36. Alright, last one. Cobalts. Alright, what do you got, Ethan?
27.
That's it?
30. 27, 30. 30, 25.
Wait. Alright, 27 protons, but it has a mass number of 59. So how many neutrons?
32.
32. And then how many electrons? Because it had a 2 plus charge.
36. Oh, 34.
Okay, there's 25 protons in
30.
it. And it has a 2 plus charge. Remember, each proton is a positive 1 charge.
25.
Good job, that's 25. So just work it out slowly. Don't try to do it too quick in your head. So 25 electrons. Alright, Chris, do you have any questions about how to solve those? Alright, the main thing for you is you probably went too quick in your homework, so just make sure you're slowly
The
moving.
quiz they're gonna be periodic table, are they gonna give us the atomic numbers?
Okay, we can number.
So it's gonna be easy, just math.
Well, just remind that it should have been
It
easy
can't
in
be
your
done.
homework on Friday, but you did it wrong because you were
I
going
didn't
too
look at
quick.
the periodic table.
Then make sure that you're looking at the periodic table or paying attention to what
Remind
you're doing
yourself.
for it. They'll probably give it to you like this, where it gives the atomic number at the bottom, but make sure that you're paying attention and just not just going too fast for your quiz.
Atomic, but it doesn't give you the whole number at the top.
Yes, well, possibly, depending on what it is, depending on what it's asking for. Slow down. That's the main thing, just slow down, so that we can get through. Alright, number 5, the element europium, or it looks like europium. It exists naturally, and then it tells you that percent for the isotope, the next percent for the isotope, and then it says calculate the average atomic mass of europium. So, looking at this one, how do you find the weighted average atomic mass? How do we figure that out? Ethan, you remember how to solve this?
You multiply in the animal. Or multiply
Yeah, it works for it. I was a little bit confused on what you're going with for it, but yeah, that's it. Alright, so whenever you're making the percent into a decimal, what do? Alright, Chris.
Move it to the zero.
Yep, alright, so for this one, it says it exists as 47.81%. So turning it into a decimal, what does it become?
14781.
I'm just gonna get rid of it that way. Alright, so here's the first percent. Alright, what is the mass for that isotope, Ethan? So 47.81%. You're gonna have to probably read it in your book because it's a string of numbers.
I got it. I can go
Okay, well,
over.
let's give him a turn. That'll see you.
150.9199 U.
Yep, so 150.9199 U. Remember, what's the U stand for?
Atomic mass.
Good job. Alright, Chris, what do you have for the second one for the percent? What does it turn into?
Oh, I need to write it down.
Okay. So what does this one turn into with the percent, Ethan?
I'm
Okay, okay.
The percent turns into 152.92. Oh, wait, when you multiply them?
Okay, no, just take the 52.19 turn it.
0.5219.
There you go. Alright, so that's how, so that one turned into the decimal. What is the mass for that particular isotope?
152.9219. Or 1.
Yep, nope, that's it. 152. I lost my spot while I was writing. 9212. Alright, so you multiply these two together and then add it to the product of these two.
Multiply those two together.
The top two, since this is the percent or the decimal version of the percent of this amount, you multiply these two together. And your calculator, because your calculator is a single step calculator, you're probably going to have to use parentheses to solve it. So that way your calculator doesn't think you multiply these two together, add it to this one, and then multiply. Because you're taking it to where you want this entire answer and this entire answer added together. So you want to multiply these two together, plus press the plus sign and then open parentheses, multiply this number times this number, close parentheses, and then press equal. That'll tell your calculator how to
Can you
do
say
it
that
in a
one?
step. What?
You said it all again.
Yep, so you're gonna tell calculator type in 150.9199 times 0.4781, add sign, okay,
0.9199 times 0.4781 equals.
okay, and then plus the add sign, like press the add sign, open parentheses, 152, I forgot my little symbol,
Yeah.
0.9212 times 5219, close parentheses, and then press equal. So that way it tells your calculator, take this whole number's answer, add it to this whole number's answer.
151.964375.
Say it one more time.
151.964375.
That is it. Alright, so let's practice with sig figs really quick. But you're right, it's 151.964, and then it just keeps going because I got tired of running. So for this one, for sig figs, you want to go off, so this is ultimately addition because it's this product plus this product. Our now, since it's ultimately addition, do you go off sig figs by the place or do you go off the number if you're looking at addition? Because that's the last step that we do. Alright.
Number. Place.
Place. Alright, so this was originally 47.81 and this was also 52.19. Alright, so what is the place I should have or use in this number? So don't worry about the converted versions, you go off the starting point. So what is the last significant place in this number? Chris?
What is the last what?
Significant place, like what's the, like how far out does it go with sig figs?
Infinite, right?
For this number?
You guys said like it's 1.
Yep, so the 1. So this is the 100th spot, so that means my answer has to round to the 100th spot. So what would this answer be in the 100th position? It's okay if you rounded, we're still practicing. Okay.
51.96.
Yep, so you would round to this spot. And remember, what's your units, Ethan?
AMU.
Good job. So AMU, or if you just wrote U, that's fine. AMU, this is the newer one, but U also works. Alright, we'll practice more with this in a minute, but because of the quiz, okay, this is not on the quiz. So I just want to make
Thank
sure.
God.
We'll practice more with this in a minute, but I want to make sure we go over all the
I have
information,
a
get you ready
question.
for the quiz. Okay.
Are you gonna tear the thing up now since I did it?
Nope,
I
you have
wanted,
to check
I
the
wanted
year.
all my paper. It's
You have to show me after class.
I have
After
a
class.
quick
It's my time right now.
quick
Just
question.
wait. Okay.
So on the first two numbers, like, over, those two numbers, the long ones, the first two, like, up and down. That one and the one below, I moved the decimal place over, but, so my decimal was off a little bit.
Why?
Because I thought you're supposed to.
Alright, you only move it for the percent, put the percent into a like not a fraction, a decimal.
And for the smaller numbers, that's what you do.
You can just leave them just as they are, yeah.
The smaller numbers, that's what you do for the significant figures.
For the smaller numbers, for these, they'll give them to you. Some of the practice ones, they pull them way out. I don't know why. The ones in the test will not be pulled out super far because they get super cumbersome to work with. So don't worry about it, but since most of the time you're given it in a percent like this, you're almost always going to round to the 100th spot. Alright, so does that answer your question?
Got it.
Alright, so let's go ahead and let's review those pages and clear up any problems on those pages before we take your quiz over those pages specifically for it. Alright, we're going to we'll do the dice game, but we'll just alternate back and forth between you two. Whichever one is the So,
I think I'd rather have 2 review days than just lab.
it's one of those,
come on.
I kind of,
Democracy.
can you do democracy?
We do a democracy whether if we do 2 review days or do a lab and then review day.
But I'm watching the clock. Because the quiz and stuff is more important than the lab, because I know how long the lab is, if we don't have time to finish it today, then yes, we're gonna
Is
go over
this
it.
video?
Mhm.
So,
So it's one of those, the test is more important than the lab, so because of that, I wanna make sure you're ready for your quiz first, before we just watch. If we don't do it today, we'll just do it later on the week after the test, so it's not like you're gonna miss the lab, we'll watch it eventually. Alright, so thinking back over it, I'm in the wrong chapter, that would have been.
Yeah, I wasn't worried about missing the lab. I just wanted 2 review days so maybe after we're doing it.
Yeah, which is fine too, but no, we can't do it all the time, so don't rely on, oh, we will always have 2 review days. No, because it does depend on how fast we move in the week and scale, because some days I just can't do it, but there is a lot of math in this chapter. I wanna make sure that you get your math down for this chapter as well.
It's the only chapter that's really base on math, like heavy on math.
There's a lot of chapters we're gonna do there. Remember, chapter 1 also has the temperature changes, so we're gonna go over those as well,
Next
so.
chapter.
What?
Next chapter is more terms.
It's more terms, it's balancing equations, so if you remember Ethan from physical science, the balancing equation like charts, oh, never mind. So it's balancing equations, so it's different,
why I
it's a
have-
different skill. It's okay. Alright, so clicking back over it, so what is the negatively charged part of an atom? We'll start with Chris, we'll just go rotate back and forth.
Electron.
Good job, roll your dice. Forgot I've had the plants up for a while, so Quentin and Jamie have been learning about plants for the past like 10 minutes by accident. Alright, so what do you call the positive part of the proton?
Proton.
Yep. Alright, what is the neutral part then, Chris?
Neutron.
What is the neutron? Alright, what was discovered with the cathode rays? Protons, neutrons, or electrons?
Oh, you're talking to me?
Yep.
Protons. No, I meant neutron. I meant electrons. Electrons.
Which one? You can just keep swapping.
Neutrons.
Nope.
Electron.
Electrons. So cathode rays, electrons. Alright, which one was discovered with the canal rays? Don't say electrons
Neutrons.
again. You sure?
Yeah.
You sure?
Yeah.
No. Protons. Cathode rays, electrons. Canal rays are protons.
I got 5, 2, 5, 5. I've rolled 3 5s out of 4 rolls. Do you know the chances of that?
Keep going. Keep going. Alright, oh, what makes up nucleons? There are 2 things together.
Protons and neutrons.
Good job. Alright, what do we think makes up protons and neutrons? Again, we're not sure, but this is what the best current theory is.
Quarks.
Quarks. Good job.
Quark.
Alright, okay, who proposed the plum pudding model with the idea that it looks like a cookie?
Thomas.
Thomas, so J.J. Thompson, make sure Thompson, so spell been spelling errors, or Thompson. Alright, who proposed the planetary version of the model, where it's, you have the nucleus and all the electrons are orbiting around it? His last name begins with an R.
Wait, what was that last one?
J.J. Thompson,
Okay, and
plum pudding model.
okay.
This guy, planetary model.
It's a weird R name, right?
Yeah.
It's like, red. So it's weird.
It is weird.
It's like rhetoric or something.
I'll see if Ethan and being a close.
Nope.
If not, okay. Oh, okay. We'll let you have it. So Rutherford.
Oh,
Rutherford.
look at that, man.
I believe it's Ernest Rutherford is his first name.
Rutherford.
Rutherford.
Yeah, Rutherford is how it looks. Rutherford.
What's his first name?
I believe it's Ernest. I don't think your book tells you on this page yet.
Okay, well I guess we'll put it.
Yeah,
on.
don't worry about it. Don't worry
And he
about
did
it.
what again?
He came up with the planetary model that you have the nucleus and all the atoms are orbiting it. This isn't quite accurate, but it works. Your book will tell you more about it later on. Alright, what do we call, or what determines the identity of the element? Protons, neutrons, or electrons?
Protons.
Protons. What do we call the number of protons? We have a special term to refer to the number of protons.
Okay.
Yep,
So atomic number.
atomic number. Alright, what do you call then the number that refers to the protons and neutrons together?
Nucleons.
Okay, that's a term, but what do we call it, like if you were, like if I was, calculating 6, so, like what is the number that refers to protons and neutrons together?
What is the number?
Yeah, like, what do we call
Atomic
it?
number.
Okay, atomic number is number of protons.
Let's start with.
M.
It's right there.
Okay?
Mass number.
Mass number. Remember, atomic number, number of protons. Mass number, protons and neutrons together. Alright.
Oh.
What do you call a substance that is losing or gaining neutrons? So it's the same element, but some of them are heavier than others. I use the term a lot to refer to this up here. 'Cause
What's
I'm
this term?
what?
What's this term?
What is this term?
Wait, what? What was the question?
Because you got mass number. What do you call an element that has a different number of neutrons? So you could have,
Isotope?
good job, isotopes. It could be like carbon 12 or carbon 14. What do you call a element that has a different number of electrons?
Ion.
Ion. What if it has, let's see, less
That was not a
electrons?
good roll.
You can roll it. What if it has less electrons? Is that a cation or an anion?
said, wait, what? I thought
Okay.
Ion or anion?
So if it has less electrons, so it has a positive charge.
ion,
Okay, is it a cation or an
a
anion?
positive charge, so cation.
Cation. Yeah, I talked about this super quick the other day. So cation. What if it has more electrons? What's it called then? Okay, but more electrons specifically.
Anion.
Anion.
I said certified like an ion.
Yeah, I just heard ions, but I want to double check to make sure. Alright, can I change the number of protons to fix my electrical charge?
No.
No, because what happens if I change the number of protons?
It's in the number of electrons.
The number
I
of
mean,
what?
electrons.
So if let's say I have a calcium that has a negative charge, so I need it to be balanced. Can I add another proton to fix it? Why?
Because you just can't, chemistry says you can't do that.
He did that nice 50-50
Alright, well why can't you, Chris?
because it will change the entire element.
Yeah, it'll jump
Do I
over
get to plug
entirely.
that?
What?
I can plug that.
Yeah, bro.
Wow.
I got a 1. I got a 1 2 times in a row.
I'm curious.
Oh.
Alright, what do you call an atom that has gained electrons?
What?
What do you call an atom that's gained electrons?
Gain electrons.
Yeah.
What does it start with?
A. Make sure you're paying attention.
Anion?
Yes. What if it's lost electrons, Chris? Which one?
Anion.
Cation. Wait. Oh, let's see. What was the experiment that was used to determine the electron's charge? Talking about different. Was it the gold foil experiment, like the oil drop experiment? Was it the cathode ray, canal rays? Which one was plum pudding experiment? Which one was used to determine the electron's charge?
Say the options again.
What experiment? So like gold foil experiment, you have the canal rays, cathode rays, oil drop experiment. Which one was used to find the charge? Not just find it, like find the charge specifically.
The one, the options, like what was the option again? Like
Gold foil.
gold foil, that's gold foil. That's the one.
Nope.
Cathode ray.
Okay, they discovered the electron web, but what was the one they used to actually figure out what the charge was?
So there's the cathode one, the one that you said, what was the other one?
Oil drop experiment and then the canal rays. And
Canal
then
rays. No.
canal ray, I didn't hear.
Yeah, I said canal rays.
Nope. All right.
Oil
take it
drop.
up. Oil drop.
Oh.
Oil drop. Last one. Gold foil. They discovered that okay, it's all you have your protons and neutrons in the center. So that's the gold foil. So that's whenever everything's in the center. They discovered the electron's charge with the oil drop experiment. They discovered the existence of electrons with the cathode rays. They discovered the existence of protons with the canal rays. All right. Anyone have any questions about the experiments?
No.
Anyone have any? Okay, cover that, cover that, cover that, cover that. Oh, what is the mass units we use to measure? We use to measure the mass of an atom because they're so small we can't just use grams. I think it's back to you.
That's a mess.
What?
So that's all the mess.
No,
Yes,
it's
it's
a
just-
unit. Like it's a measurement unit.
Area.
Yep. So which stands for
Atomic mass unit.
atomic mass units. There's no way to like describe it well. All right. What is the laboratory device that's used to measure like the weight of these atomic masses?
Mass spectrometer.
Good job. Alright, what type of average is used to account for all the natural abundances of the isotopes? What do we call it whenever we're finding it? It's not just the average, it's called a something average.
Atomic damage.
Nope,
I know it is.
Is it
Come on,
something?
man.
nope,
Me,
Wait, show me.
W.
W?
W.
Oh, weighted mass average? Mass weighted, or
Yeah, why?
weighted average?
Weighted average. Alright,
What is it?
I'll give you
What
one
was that
more.
again?
Weighted average.
Wait, what was the definition?
It's used to account for the natural abundances of the isotopes plus their weights.
Oh, weights. Okay, never mind.
Alright. Last question for you. Who came up with the planetary model? Just making sure.
JJ. Rutherford. Rutherford.
You better not get that.
Rutherford.
The
Rutherford.
first name's not
Not-
given in the book. so
Not
just
JJ,
take-
but Rutherford.
Rutherford is correct. Roll. Alright. Add your points really quick. Anyone got 25 or more?
I definitely have 25 more. 5,
Let me count.
5, 10, 15. 46. What did you get? 46. I got 59. Of course you did.
Alright, don't forget your hand in that class. Alright, go ahead and check out. Okay, you two are far enough apart, but clear your desk of everything. You can have your calculator out if it makes you feel better. Depending on how good you are at your math, you might want to have it out, so just leave it out. So that way you don't have to worry about getting the wrong answers. I'm going to come get the dice now since I can still hear the sounds of them. Alright. Okay.
This is gonna be hard.
Alright, so just make sure you're paying attention to what you're doing, so read for the short answer. Alright, so 4 and 5, it's asking for number 4, how many electrons are in lithium, and then number 5, how many neutrons are in strontium. So pay attention, if you want to use your calculator, you can, but it's asking specifically for electrons and specifically for neutrons. Alright, read through the rest of it. Number 6 is asking specifically what do you call an atom that's gained electrons. So don't just put the general term. It wants specific ones. So pay attention to what you're doing. Jamie and Quentin, you should have this quiz in your packet. I also emailed it to your parents in case it got lost. So just make sure that you either go ahead and ask them for it or you ask them to print it off. I emailed your parents yesterday about it though. For number 8, it's asking about the electron's charge specifically, not just asking what discovered it. So just pay attention to what you're doing. Read. Just sit quiet. Yes, Ethan.
Number 2, is that like an experiment or something? Like an experiment?
Yeah, it's what the it's asking you like what is the phenomenon that consists of electrons flowing in and flowing between electrodes in the vacuum tube. It's asking you basically how was it discovered basically, what were they noticing? But the experiment is named after it too. So that should help you out. Yes.
Does it work best in 2 answers?
Nope. Nope. Read your question again. Make sure you read through the whole thing. Make sure what she's asking for.
Number 1.
What?
Number 1.
You just read it.
What subatomic particle of the atom has no electric charge?
That's supposed to be.
What subatomic particle is neutral? Has no electric charge?
Did you write these or something?
Oh, no, not this particular one, no. You might need more time. Alright, go ahead and get it to me like a bud. We can't go over the answers in class, just in case Jamie and Quentin were unable to take it right this second. So, we'll go over it tomorrow before the recording, or you can ask me, hopefully gentlemen, later on today. I should hopefully have it graded by the end of school today with study hall, because I'll have a ton of stuff coming in. But, if you didn't know what it was talking about, be sure that you look it up in your book. Alright, so let's go ahead and let's practice on page 35. The application, we're not going to have time for Black Lab, so we'll just practice and make sure you know your math really, really well for this section. Alright, so look at the application number 1 and number 2. So on page 35, application number 1 and number 2. Calculate the average atomic mass of magnesium given the following percent abundances and isotope masses, and then it gives it to you. So you're finding the weighted average. So this will be one practice problem. So go ahead and start setting it up yourself, and then we'll talk through how to solve it as well for it. So try to see though if you can get the correct answer without me having to help you out that much with it. So go ahead and get started with that.
Sorry.
Page 35, application, towards the middle of the page, application number 1. And then if you think you got that one and you want to go on to number 2 by yourself, you can as well. Try to do number 1 first. I'm going to scoot over to make sure I have enough room for this. The numbers are really large, just be sure you're being careful. Done with problem 1 where they think they have the correct answer?
About the.
Okay. Check your answer, raise your hand if you want to be the brave soul that thinks they got it right. Alright, Ethan, what you got?
24.3 atomic mass units.
Super close. You're off by 1. Because remember, what place should you round to?
Oh, 24.31 atomic mass units.
Good job. Alright.
I didn't think about doing that.
It's okay, you just have to remember for sig figs.
Well, I didn't remember it, but I saw the 0 might have fit. Never mind.
Yeah, remember this is 10.00, so do these zeros count? Yes, they do. So just remember that for these, you almost always want to go all the way out to the 100. Alright, did you get this answer as well, Chris? Alright, anyone have any questions about how to solve this one then?
It's easy.
Okay, it's okay. Yeah, so it's one of those. Once you learn your steps, it's not hard. You just remember, okay, multiply, add, multiply, add, okay, there's my answer. So, alright, let's do number 2 then. Number 2 is a little bit easier because you're only working with 2 substances, you're only working with 2 isotopes and not 3. So go ahead and write that one down and practice with that one. You think you got it right, Chris? Alright, give me your answer.
I got 11.05.
Alright, not quite. So double check your answer again. So let me make sure I copy it down correctly.
Error.
You probably forgot to close parentheses or something then. So make sure that you multiply these two together, plus your plus sign or addition sign, open parentheses, close parentheses, and then press enter again. Because if you just close parentheses, it's telling you what this product is. So press enter again if you press addition first, so it'll fix it and it'll do your entire calculations. Okay.
6.48.
6.4?
Yeah.
Okay, you're missing one number in between them. So check it one more time. So let's talk through this one then. So what?
Give me a second.
Okay. Be sure to change these into decimals. So I left them as the percent, but make sure you're converting them into decimal equivalents. Don't just leave them as percent signs.
Yeah, just 1 second.
Y'all did good in the first one though. I thought that one was the harder one. Just make sure you're slowing down, doing all of the proper steps.
6.940.
Good job. What's your units?
Something actually.
Good job. So that is the answer for it. So check your second first. Make sure it's the entire top. Make sure you convert this into percent so it becomes 0.0759. That might be where part of the trouble is coming from. So change it, make sure, and then for this one, just get the decimal point moved. But again, just be careful to remember to move your decimal point, multiply the entire top together, open parentheses, well, addition sign, open parentheses, this whole thing, I'll write in a second.
6.940 and move.
Rounding it to this spot becomes what, Ethan? Well, since it was, what was your end percent first?
Wait, what?
Alright, so, remember, with addition and subtraction, do you go off place or do you go off number?
Place.
Place, so if it's ended, here, where does it have to round to for here?
The second.
Yep. So what does it become?
6.91.
Good job.
I didn't know that because I converted it, and that's what I thought I was going off of before.
Yeah, no, you want to go off of where you start because you're going to get other ones later on, and you want to go with, okay, where did I start with, not with where I converted to. It'll make it easy, because later on, whenever you start working with Celsius to Kelvin, Celsius will give it as like 59%, but once you, well, 59, once you add it to the 273.15, you end up with a decimal point for it, so you don't want to go off that. Alright, anyone have any questions about that?
Pretty easy.
Yep, it's pretty straightforward, but just remember to convert your percents, add, open parentheses, multiply, close parentheses, and then press your equal sign. Alright, any questions about yours? Alright, I only have 10 minutes left, let's go ahead and let's review this still. So this will reset, I don't remember who had what color. Who had what color? Here's your blue then. Keep out your piece of paper so you write down term definitions you don't know, because we're going to go over the math probably.
For more candy or just?
No, you can earn more candy, but just the round resets, so you both have 0.
Oh, okay.
Yeah. So round resets, but here's your second chance basically to earn candy in the section. We went through a good chunk of chapter 2 already, but keep in mind the periodic table is on the test. So we're going to go ahead and hit these really quick, so we're just alternate back and forth, so we'll move through these fast for it. I'm going to just hold up the card. Alright, Ethan, we'll start with you.
Chlorine.
Alright, roll. BA,
Barium.
that's it. Alright, you,
Uranium.
fluorine.
F.
Good job. Remember, it is spelled F-L-O-U-R, sorry, F-L-U-O-R, so that's where it's spelled.
F-L-O-U? Or
F-
U-O?
F-L-U-O-R. I have to think it through because I'm dyslexic too, so I have to think it through very carefully. That's the reason why you both got spelling errors, so be careful.
I think I
Fluorine.
was-
Just make sure.
I thought it was chlorine I got wrong.
You both got a spelling error, and I think it was both on fluorine, so just
I
have
think
to.
I spelled chlorine right.
Yeah, I think you did spell fluorine right. We're gonna double check later on, so make sure you know them. Alright.
That was mercury.
Oh, sorry. Alright, CA, Ethan.
Carbon. Calcium.
Calcium. Right.
I got that mixed up on with that.
What does
Bummer.
it say?
Oh, HE, sorry.
Helium.
That's it. P. What?
Plutonium.
No.
Potassium.
One
No.
more guess.
It starts with a P?
Yes.
Hint?
No, it starts with a P.
Have we did this one?
Yeah.
Phosphorus.
Phosphorus.
Forget phosphorus, man.
Or phosphorus. Alright, back to Ethan and his crystal.
Argon.
Argon. Lead.
Lead. Oh, what is this? Start with.
This is a weird one.
Let's start with.
Nasty peanut butter and jelly sandwich.
No, that's community.
Jelly sandwich, that's how students remembered it last year. What's another?
PB.
PB. So remember PB. Alright, K.
Potassium.
It's potassium. This is a weird one.
Special K.
Yep. Sodium.
This is sodium.
No. H.
Hydrogen.
Yeah. S.
That's something else?
This one does start with an
It's stanky.
S. It is actually.
Sulfur.
What?
Sulfur.
Good job. But it's not gonna say stinky on the quick test, so make sure you know it. Alright, Fe.
Iron.
Iron. CS.
Cesium.
FN.
Start with an S.
What?
Does it start with an S?
Starts with T.
T, is it, starts with T?
Starts with T. It doesn't match it. It's going with the old name for it.
Titanium?
What?
Titanium?
Nope. You can one more guess. Cause I'll let you know if you guess.
Right?
Nope.
Tin.
Tin. Remember, sin is kind of like sin, rhymes with 10. Put it off the
That's
side.
how I remember it.
I mean, that's how last year's students remembered it too. Alright, BR.
Bromine?
I spin here because of the dice.
Brominium?
Bromedium?
Is it bromine?
Bromine.
Bromine.
Yeah, it looks like bromine, but bromine. Alright,
What's that say? PU?
PU.
Start with a P?
Yeah,
Plutonium?
plutonium.
I thought that was PT.
This is PT.
Start with P?
Yep. Most expensive metal. Platinum. So platinum is PT.
Why is platinum so expensive?
Because we use it in so much stuff. We'll talk about it later on. But yeah, we use a little bit of it in so many things. Alright. Li.
Lithium?
Lithium.
I think it's off around like plutonium.
What one?
I think it's off around, like from activation of
That? Whatever else you think of it. Okay.
and then, and
And then-
manganese?
Manganese. Oh, I put this one back in the middle. Alright.
Sodium?
Seven. Cu.
Copper?
Copper. Hg.
Mercury?
Mercury.
I feel like it'd be a game of who had the best rolls.
What?
I feel like it'd be a game of who had the best rolls, so we're getting all of them.
Yay!
Xeon.
Xenon.
Williamson.
And I?
Ni.
Nickel?
Nickel. Si.
Silicon.
I've
Yep.
gotten four times in a row.
Alright.
3 times.
O.
Oxygen.
N.
Nitrogen.
C.
C is carbon.
Carbon. Alright. Ne.
Hi.
Ne.
Ne.
Let's start with
N.
something.
Mhm.
Oh, is it,
Cheater.
I'm not looking.
Okay.
Is it, starts in a,
Mm-hmm.
you know what?
Yeah.
You might just be having I'm just a brain blank right now. You'll know it in a second.
Is it like, neon?
Yep. Neon. Alright, zinc.
Zinc
Zinc.
is the
ZN. Gold.
8.
AU. Chromium.
CR.
CR. Iodine.
I.
That's it. Arsenic.
AS.
That's it. Aluminum.
Certainly.
Aluminum.
AL.
AL. Krypton.
CR.
No.
Nope, no. Krypton.
I'll let you get another guess.
9.
C. K. I'm at K.
Just K?
Yeah.
Nope, that's potassium.
KR.
KR. Alright. Radium.
Alright.
Alright. Magnesium.
MG.
Mg. Radon.
RN.
Yes. Silver.
Let's start with.
There's so many
What's
ones.
the symbol?
It is not, it doesn't start with an S.
No, it does not start with
Is it AG? No,
AG.
not.
AG. AU is
Four
gold.
to go. 4 to go.
Alright. I'll do the last couple cards and I'll give you your homework. Alright. Beryllium.
What?
Beryllium. Beryllium, technically.
BE.
BE. Cobalt.
8.
CO.
CO. Rubidium.
RB.
A drug.
8.
Strontium.
7.
Is it ST?
Not ST. Get one more. Good. I'm good. One more good.
Wait, what was it?
SR.
Strontium. SR. Alright. Y'all need to look over
I have like
Silver.
400 bullets.
krypton, tin, lead, and phosphorus. So look over those 5 because it's out of time. Alright, your homework.
85, 85, 95,
You're going to
105, 110, 112.
here, we'll check it in a second. Alright, for your homework, you're gonna do problems on page 16. You're gonna do problems.
128.
Yeah, check that. You're gonna do problems 1, 3, 5. It's gonna feel like a lot, but it's not that bad. So it's
Page.
problems on page 16. Problems on page 16. 1, 3, 5, 6, 8.
That's a lot.
It's not that bad. You're just on some of them. It's like on some of them. It's like
Seven.
how many sig figs is present. So it's not that
I'm
bad.
just
Is that
kidding.
it?
All right, I'll say it one more time. So page 16, problems 1, 3, 5, 6, 8. So spend time on
I was scared
it.
that our test was going to be tomorrow because
No.
we had the spelling test tomorrow too.
No.
And,
Alright. How many points did you have, Ethan?
I'm just throwing.
How many did you have?
120.
All right, go reach game. The bell's about to ring. Go to top 5. We're gonna have like 10 minutes.
Chris.